Good morning. Myself, Dr. Maheswara Rao, Department of Civil Engineering, Institute of Aeronautical Engineering. The course name is Fluid Mechanics. The topic is Buoyancy. So, course outcomes. The meaning of course outcome is the students will be able to solve or understand after completion of the course. So, here course outcome 1 is the students knows the definition for the fluid and the properties of the fluids, surface tensions. So that will is course outcome 1. So the course outcome 2 is the Newton's law of viscosity. So the fluids are classified based on the Newton's law of viscosity. So Newtonian fluids, non-Newtonian fluids. So the fluids which obeys the Newton's law of viscosity, those are called Newtonian fluids. The fluids which are not obeying the Newton's law of viscosity, they are called non-Newtonian fluids. So, and some problems related to the viscosity. So, it is under course outcome 2. And course outcome 3 is the capillary rise or fall. So, that means whenever you insert a small diameter tube in a fluid, some fluids will rise the level inside the small diameter tube. Those are called capillary rise. And some fluids will fall the level inside the small diameter tube. Those are called capillary fall. So, capillary rise and capillary fall. So, it is under course outcome 3. That course outcome 4 is the surface tension and applications. So, that means that any fluid will have tension at the surface, outer surface. So, that is a surface tension. So, that is the course outcome 4. And course outcome 5 is the compressibility. That means, and the external application of any force, if the volume changes, the fluid volume changes, they are called compressible fluids. If volume change is not occurring by the application of external force, those are called incompressible fluids. So, gases are examples for the compressible fluids, and water is the example for incompressible fluids. So, that is the course outcome 5. So, whereas course outcome 6 is the frictional losses. That means whenever fluid is flowing in the pipe, so there will be friction losses because the internal pipe surface and fluid while traveling, it has frictional forces, so that the energy loss will occur. So, those are called fluid friction or fluid pressure. So, frictional losses, those will come under the course outcome 6. So, today we will deal with the buoyancy. So, what is the buoyancy force? See here in this figure, okay, in this figure, this is a empty bottle, no cap. But if you press this bottle, it will not enter into the water. So, because the internal fluid gas will apply opposite force here. Okay. So, whenever this water pressure exerts, so this air will not allow to go down here. So, if you take another bottle, so with the lid, okay. So, if you put on the water, say it will float like this. And if you tries to apply force by your hand, it goes a little bit inside the water, but it will not reach the bottom of the bucket. So, this force is downward in directions, okay, downward motion, the forces we are applying. But here it is not going easily into the bucket of water because the water is having a property of upward force. So, the water will exert upward force. So we are applying with hand, that is a downward force, and the water is applying the upward force. Okay. So that's why whenever you leave your hand, automatically the water will come up because of this upward force. So it is a property of water. It will exert upward force. It is a property of water. So, which is called here buoyancy force. So, here G is the weight of that body, weight of any object acting downwards. Similarly, the buoyancy force, that means upward force, will be acted by the water. And some objects, if you put in the water, partially it submerges. So half of it will submerge, and some are fully dipped. So what is the reason means? Okay. So whenever this weight of the object is lesser than the upward pressure, then it will float. And whenever the weight of the object is heavier than the upward pressure, okay, then it will submerge, fully dipped. So here we can calculate the force F1, upward force F1, and the pressure P1. A1 is the area of that particular object. Area of that particular object. So F1 is equal to P1 into A1. Similarly, F2 is equal to P2 into A2. So as in this. So we can also see the one example. So if you put a bucket in a well, okay, what will happen? So while bucket is inside the water, so this is the water, it is already water, the bucket is inside the well water, so that if you pull it, then it will looks like a lighter weight. So it shows a lighter weight. Whereas if it pull again, whenever it comes above the water level, so here above the water level, then the weight will be increased. So what does it mean? The weight of bucket of water is same, but whenever it is there inside the fluid of water, because of the upward force of water, that is the buoyancy force, so the total weight of this bucket is reduced by the equal amount of the displaced volume of that water. So it is heavier here because it is outside the fluid water. It is lighter in weight because it is inside the water fluid. Similarly, if you take a weight of 700 grams, so you take a 700 grams, you can pull a connect to the weighing balance, spring balance. Okay, so whenever you insert into your water, so what will happen? Upward force will be acted. That means buoyancy force is acting. Because of that, so initially 700 grams is showing the spring balance. Now it is showing only 600 grams. So because the upward force here, by means of these two figures, okay, 700 minus 600. So 100 grams of upward force is acting by means of the water. So which is called here buoyant force. So here the factors affecting the buoyancy is one of that is volume of object. So how it depends, buoyancy is volume of object. So if the more volume, okay, so the weight replaced, the weight of volume of water replaced will be more, so that it floats. So if the weight of water replaced is less, because volume is less, if volume is less, then if you put inside the water, so what will happen? The weight displaced by that volume of that object is less, hence it will dip or it will sink into the water. Okay, so that's why volume is the one factor. So if you see the ships or boats, whatever it may be, it is a metal sheet. So if you make it a small metal, it will be 1 kg. If you dip into the water, it will sink because the volume of total 1 kg mass is smaller. So the same 1 kg mass, if you make it into sheet, then its volume displaced, it will be large whenever you put into the water by making it as a boat. So then volume of the object is a one factor. Another one is density of the liquid. Okay. So if more density is there, so density is that means the buoyancy force is directly proportional to density of the liquid. So if the liquid density is more, buoyancy force is also more. Density is less, buoyancy force is also less. So that's why if you swim the river water, the density of river water is less, so that you cannot swim or you can sink into the water easily. But whereas the ocean water, which is having more weight, okay, so then more density, that's why you can swim in the ocean water more longer compared to the swimming in the river water. So that is the density of a liquid. So you can see the ship here. Ship is floating. Okay. So what is here? mg. Mg of ship. Okay. Mg of ship means weight of the ship acting downwards, and this is buoyancy force is acting upwards. That means the volume of water displaced by the ship volume. Okay. So then it will float. So if weight is more than the buoyancy force, then it will sink. If weight is less than the buoyancy force, that means weight of the ship is less compared to the buoyancy force, then it will float here. See here, the ship weighs less than the water it displaces as it floats. So the ship, if you put inside the water, that means actually ship will be like this. So this is not visible, but this much volume is displaced. Hence, the weight of water displaced by the ship is less than the, see here, this is the weight of ship and weight of displaced water. Okay. So if ship weight is more than that, it will sink. If the ship weight is less than, that means ship weight is less than the weight of water displaced, then it will not sink. The ship will float. See here, buoyancy. So what is written here? Assume body is immersed in a fluid as shown below. So you can see in this figure. So it is a weight. So you are immersed in a fluid. So an upward force is exerted by the fluid onto the body. So this is the upward force. It is acting upwards. Upward force is acting by the fluid here. This upward force is equal to the, that means how much upward pressure is generating there. So that is nothing but the weight of fluid displaced by the body. So that means whatever the body weight, because of the body volume, how much water is displaced, how much weight of water is displaced. That much upward pressure is acting onto the body. This is called the buoyancy force. Force of buoyancy or simply buoyancy. So it is a force of gravity. Then center of buoyancy. So actually the buoyancy force is acting all area of the water, surface area of the contact area. So then what is the center of buoyancy means? Just like a center of pressure, whenever a body is immersed in a surface immersed in a water pressure will act, and resultant of that water pressure will act at one point which is called center of pressure. Similarly here, center of buoyancy. So buoyancy force will act on all the surface, contact surface, but the resultant buoyancy force will act one point which is called center of buoyancy. See here, the definition as the point through which the force of buoyancy is supposed to act. That means it will act at a one point. That is called center of buoyancy. So here, as the force of buoyancy is vertical force, here buoyancy, the weight of body is always acting downward direction, weight of the body. Similarly, the upward direction force, buoyant force is always upward direction, vertical direction. Okay. Buoyancy force is always vertical. So is equal to the weight of the fluid displaced by the body. So buoyancy is nothing but it is a vertical force and is equal to the weight of fluid displaced by the body. So that is the buoyant force. The center of buoyancy will be the center of gravity of the fluid displaced. Here, two things are there. Center of buoyancy and center of gravity. So if any object is there, like ship or whatever it may be, okay, so it will have a center of gravity. So this is the CG. The entire weight of that body will act at the center of gravity. Similarly, the center of buoyancy, that means weight of water displaced. Okay, so then center of that displaced weight of water, that is a center of buoyancy. So center of gravity of the fluid displaced. So whatever the displacement of fluid, the center of gravity of that fluid, displaced fluid. So that is the center of buoyancy. So volume of water displaced. So how will you know the volume of water displaced? It means it is nothing but the weight of water displaced by density of water. So density is equal to weight by volume. Okay. So density is equal to weight by volume. So if you want volume, so you can get Y by, that means weight by density of fluid. And another word is there, metacenter. Okay. So you can see the figure. So while we are giving the small tilt, so what is happening here? So it is rotating about some point. Okay. Then you see here, it is defined as the point about which the body starts oscillating when the body is tilted a small angle. Suppose if you tilt a ship, a small tilt, then it will rotate or it will start oscillating on based on some point. Here is the point. Okay. So that point is called metacenter here. Okay. So in other words, metacenter is also defined as the point at which the line of action of the force of buoyancy will meet the normal axis. Will meet the normal axis when the body is given a small angular displacement. So that is also a metacenter. So metacenter means if you give a small tilt, okay, so small tilt for a shape, then it oscillates like this. So then the point, it based on the point, axis point is it. So that is called a metacenter here. So then you can see here, the distance mg is the distance between the metacenter for a floating body. The center of gravity of the body is called metacentric height. Here, metacentric height is there. So metacenter means, what is the metacenter? When you give a tilt, the object will oscillate at certain point as axis. That is the metacenter. And metacentric height. So what is given here? Metacentric height, distance between the metacenter of a floating body and center of gravity of the body. So center of gravity of the body and the metacenter of the floating body. So then the distance between that is called metacentric height here. So here M is here and G is here. So it is a normal axis, G and B. B for buoyancy force, G for center of gravity of that particular object. The stability of bodies. So stability of bodies means, so what does it mean? Means it will not fall, it will not sink into the water. So you can see here a stable equilibrium. So what is the stable equilibrium? W is equal to FB. That means weight of any body, weight of any ship or boat or any body is equal to buoyancy force. Okay, buoyancy force. That means the weight of this W is equal to buoyancy force. So W is equal to buoyancy force. Then another thing is B is above G. So center of gravity is here, B is here. Okay. So both are equal. B is equal to G, but B is upside and center of gravity of the body weight is below it. Then it is a stable equilibrium because this force is acting downwards, center of gravity is weight of the body, whereas buoyancy force is acting upwards, so that it is stretching. So that if it is like this also, if it is center of gravity weight like this and upward force, so that it will become in stable condition. But whereas the same W1 buoyancy force, weight of the object, and the upward force, that means buoyant force, is same, but the thing is here B is below G. So now in this case B is above the G, then here G is coming here, B is coming here. Okay, so then it is not a stable one. So it is unstable equilibrium. Okay, so both are same. Weight of the object is same and buoyant force. Both are, example say 1 ton, 1 ton. So weight of the body is 1 ton, buoyant force also 1 ton. Both the cases, but the place of the buoyancy point, okay, the center of buoyancy. So if it is above the weight of the body, it is safe, it is stable. So if the buoyancy force is below the weight of this G, then what will happen? There will be couple is formed, because see, G is acting downwards and B is acting upwards. So this is G downward direction, this is buoyancy force upward direction. Then what will happen? It will sink. So it is not a stable condition. So a slight displacement will make it is a couple. Then it will sink. So then it is not a stable, it is a unstable equilibrium. Stability of bodies. So if the body does not return its original position, see, unstable equilibrium. So if you give any small displacement, if it comes to original position, it is a stable body. If it is not come to its original position, then it is unstable equilibrium. Okay. So neutral equilibrium. So what is this neutral equilibrium? So one is stable, unstable. If buoyancy force is above the weight of the object, it is a stable. If the buoyancy is below the weight of the object, it is a couple unstable. Whereas the neutral, so here also buoyancy force is equal to W. Weight is same, weight is equal to buoyancy force. Forces are same. But B and G are at the same point. In the previous case, B is here, G is here. In another case, G is here, B is here. Another case, G and B at the same point. So this is safe, because one upward, one downward, it makes into original position. But this is unstable. Okay, unstable. So unstable equilibrium. Then if the same point, same weights, that means weight of the body, buoyancy force are same value, and also acting at the same point, then that is called a neutral equilibrium. So here, in the stability of bodies, three equilibriums are there. One is stable equilibrium, another is unstable equilibrium, third one is the neutral equilibrium. That means buoyancy force is always upside, that means above the G, that means weight of the body, then it is safe. If buoyancy force is below than the weight of the object, that G, then unstable. And if same point, both are acting, weight of the body and buoyancy force both are acting, then it is a neutral equilibrium. So you can see in this figure, here buoyancy force is above than the weight of the body. So then it is acting upwards, it is acting downwards. So then it will become, how it will become? It will become original, other vertical, so that it is safe. But whereas the buoyancy force is below than the weight of the body. Okay, then weight of body is acting downwards here. Okay, this direction, and this buoyancy force is acting upwards. Then what will happen? It will sink here. The water will enter, so automatically it will sink. It will never regain its original position here whenever you do a small displacement. So that is called unstable. So for always stable condition, weight will be at lower level, and buoyancy, point of buoyancy or center of buoyancy will be at the higher level. So if you review today's class, okay, so buoyancy force is nothing but here we have taken a bottle, okay, without cap, but we are trying to push it. We are trying to sink it inside the water, but it is not occurring because of the internal air pressure is resisting to sink in it. Okay, and water is exerting upward force. So that is a buoyant force here. And if you take a bottle with a cap, so if you put on the water, it will float. And if you apply a force downward direction, it sinks a bit, but it is difficult to sink at the bottom of the bucket here. So because the upward force will be acted by the water. So which is called here, the upward force is called here buoyant force. Okay. So whenever release the hand, automatically the bottle comes up, top surface of the liquid here, because the upward direction force by the fluid, which is called here buoyant force. So here G is the weight of the body acting downwards, buoyant force is the force acting vertically upwards here. So some of the objects will sink partially, some of the objects are sink fully, because the weight of that object is less than the weight of displaced volume of the water. Then it floats. Then if the weight of the object is less, if the weight of the object is more than the upward force, that means downward force is more than the weight of water displaced by that object, then that will sink here. So force is equal to pressure multiplied by the area. So take the example of well. So whenever you bucket of water is inside the well water, so it is having lighter weight, and whenever you pull down, pull up, then what will happen? If it comes above the water level, then weight will become more. That means heavier. So because of the no upward force while it is in the air. So if it is in the water, water will exert upward direction force. That's why the bucket of weight of water is lighter. So because of the buoyancy force, it is happening. And similarly, if you put a spring balance with a weight of 700 kilograms, after inserting, the spring balance will show you 600 grams. Then that 100 grams is the force exerted by the water, fluid, upward force exerted by the. That's why the 700 grams is not showing by the spring balance. It is showing only 600 grams here. So that 100 grams is a buoyant force here. And the things which depends on the buoyancy force is the volume object. If they have more volume, then more buoyancy force here. And density of the liquid. If the density of more density compared to river water and ocean water is having more denser and river water is less denser, then the buoyancy force also proportional. So in river water we will get smaller buoyancy force, whereas in the ocean water the buoyancy force is more compared to the river water because of its more density. And here upward direction force is a buoyancy force. That means weight of displaced fluid, and that ship weight is acting downwards here. So if weight of that ship is less than the weight of displaced volume or water, then it will float here. So actually, the ship will be inside the, like this, more volume is there inside the water. So that much of water is displaced. So because of that much huge weight of, that means huge weight of water displaced, that means it is having more upward force. That's why the ship is floating there. So here buoyancy force means if you take a body, if you immerse in it, okay, upward force will be exerted by the fluid onto the body. So the weight of displaced fluid volume of fluid, displaced weight of fluid volume, that is called a upward force. That is a force of buoyancy, or simply buoyancy force. It is nothing but the how much upward force exerted by the fluid is nothing but the how much volume of water, weight of volume of water. displaced. That much weight, that much force is acting upwards. So which is called here buoyancy. And center of buoyancy. So center of buoyancy means where this is a point where the force of buoyancy supposed to act. So the buoyancy force is acting at some point, that is the center of buoyancy. Okay. So then the force of buoyancy, vertical force, is equal to the weight of the fluid. So the buoyancy force is vertical in direction. It is nothing but the weight of the fluid displaced by the body. Okay. So center of buoyancy and center of gravity of the displaced body. So how much center of buoyancy is nothing but the center of gravity of the fluid displaced. Then you will get the volume of water displaced based on the density is equal to weight by volume. Then volume is equal to weight by density. That is the formula. And meta center. So if you give a small tilt, so then the ship will oscillate at based on a certain point, making it as axis. That point is called meta center. And this is a normal axis and a metacentric height. So metacentric height is nothing but the distance between the metacenter of a floating body and center of gravity of the body. So center of gravity of the body, that means object weight, center of the object weight of that is center of gravity to the metacenter. So that distance is called metacentric height. So what is metacenter means? Any point if you give a tilt, then the object is oscillating based on that point. So that you're making it as axis. Okay, that point is called metacenter. So that metacenter to weight of that object, center of weight of that object, that is called a metacentric height here. So stability of bodies. So you can see here, in these three conditions are there. So here, weight of the object and buoyancy force, both are equal. But both are equal, and some condition it sinks and not stable, some conditions is stable, some conditions okay, neutral. So the both weight of the body and upward force is equal. That means downward force, upward force are equal. But in stable condition, what do you need means G should be below the buoyancy force. Then G acting downwards vertically, B is acting upwards vertically. Then it is stable. So in the reverse case, so if weight of the body is above the buoyancy force, so buoyancy force is acting upwards and center of body weight is acting downwards, then it makes a couple, that is a unstable one. Okay. So the body will not give its original position, that is a unstable one. If it is returned, then it is a stable one. So neutral equilibrium means both weight of the body, buoyancy force is same, but they are acting not at a distance, they are acting at a single point. So then it is called a neutral equilibrium. So you can see this stability of bodies here. So in the first condition, the ship, okay, so ship is, if you apply a small tilt, again it reaches its original position like below the picture. And whereas this one, here, weight is above the buoyancy force. So then upward and downward directions making it unstable. So then it will sink like this. So references are K. Subramaniam, Theory and Applications of Fluid Mechanics, Tata McDaniels 2012. So Modi PN and SNC Hydraulics and Fluid Mechanics, Stanford Course 2. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.